Hello everyone. Today I'm going to be going over how to do linear programming. It's this really cool math concept I learned how to do about an hour ago, and I just wanted to tell the world. So I'm going to fire up a good old example, because that's the best way to learn, is to get in the thick of it. Alright, so here we have a question, right? Let's just read this verbatim. A calculator company produces a scientific calculator and a graphing calculator. Long-term projections, so that means that they're wizards, indicate an expected demand of at least 180, no, just 100 scientific and 80 graphing calculators each single day. Because of limitations on production capacity, no more than 200 scientific and 100 graphing calculators can be made each day. It's crazy. So, but here's the key, right? The key is this thing right here. If each calculator sold, this is scientific calculator, results in a $2 loss. But each graphing calculator that's graphing is $5 profit. That's like the key. So I wrote that down here. So negative x, since scientific is x and graphing is y. So I put those two down there, and that equals profit. And then these are the parameters that were specified up here. So there has to be more than 100 scientific calculators made a day, but there can't exceed 200 made a day, because the dungeon that the wizards are in cannot facilitate that much. And the same for y, got to be more than 80. They can't make more than 170. They just can't do it. So once you have these written down, this is honestly, like, I'm not a teacher right now. This is like the hardest part right here, is getting the equations. The rest of it's pretty easy. So we're gonna open up. You're going to get your calculator, but today I'm using Desmos, which is this really neat website made by Swedish people in Finland that actually speak Thai. Very strange, but it's beautiful and I love it. So we're just going to graph these, right? We're just going to graph these. Happy little graph, right? Happy little graph. So x got to be more than 100, but x cannot be greater than 200. But it can be equal to it. It can't be bigger than it. 80 gotta be more than 80 of the y's. Wait, just kidding. Yeah, y's gotta be more than 80. Y's gotta be way more than 80. But y cannot be greater than 170, dude. Cannot be greater than 170. And this right here, this is to satisfy a shipping contract. A total of at least 200 calculators must be shipped each day. Now that is just put in terms of y. It really is y plus x is greater than or equal to 200. But I just simplified it already for you. Usually you have to put it in terms of y, so that way you can graph it. So then it would be y is greater than negative x plus 200. And boom. Do you see right here this steamy, I like red more, this steamy hot pocket right in this business? Do you see this? This is a hot pocket of success. Not this little triangle. That's a byte that they took out of it. That was like the test byte. But this little hot pocket is the key to winning at linear programming. I'm going to tell you that straight up. That is the key, is right in this box. Because look at these points right here, right? These are your keys to success. All you need is these 5 points, which I have written down here. So once you graph it, this is, by the way, for any of the nerds who really want to know what it's called the range of feasibility. In this range, it's material, it's feasible, you can touch it, smell it, breathe it, eat it, taste the hot pockety goodness. This is the key right here. This is where all of them overlap and the parameters are correctly met. So now once we have these, what you're going to do is you're just going to plug all of these into this equation right here. So simple. So simple. I told you. It's just like stringing up a banjo, you know? You just go. It's beautiful, simple, elegant, timeless, classic. But now we have to get to work. And I'm actually going to pause it though, because you don't want to see me multiply this, kind of boring. So I'll come back to you once I multiplied all of these. Alright everyone, I'm back. As you know, I use my handy dandy calculator, and I just multiplied it. I literally just put these with the corresponding variable and I multiplied it. So for the first one I got 100, second I got 160, 0, 450, and 650. This right here, that's the key. That is the key. You won. These are your answers. So there's 100 psi and 100 graph. That's it, dude. That's all you gotta do. That's all you gotta do. You finished. Congratulations. So now we're gonna go on to another one. Hold on. I'm gonna take a pause break. I'm gonna set the other one. Use this as a chance to, like, I don't know, jump around, stretch your legs. Okay, everyone. I'm back. And here's the next problem. So rather than order rabbit food that is custom blended, so this is like really fancy stuff, it is cheaper to order food X and food Y. That makes it helpful because then we can just plug in X and Y and blend them for an optimal mix. Food X contains 8 grams of fat, 12 grams carbs, and the other one has 12 proteins and costs that much. Okay, so what I left out of here is the equation. So the actual money I'll put C for cost, I guess, because that's the letter that they use. 0.2x plus 0.3y. I'm actually going to pause the video one more time so I can write down all these points, because that'll take a while, because I'm actually really bad, as you can see, with MS Paint. But yeah, I'm going to be right back. Alright, I'm back, and I feel like I need to explain something. So I forgot to add in this little handy tidbit right here, which really helps us get these ramifications and parameters in place. In order to ensure optimal health, this test accurate results. So the daily diet, and this really just tells you what this is. So minimum of 24 fat, and carbs got to be 36, and 4 grams of protein. So once you have all these parameters, again, all you gotta do is you gotta plug it into your calculator. For me, using Desmos. So yeah, hold on. Let me just get something fired up. Okay, yeah. So this area right here. Let's get rid of this real quick. Oh shoot. Oh shoot. Oh boy. Oh. I mean, you don't even really need that parameter, to be honest. That's just telling you the minimum weight. But this right here, these points 1, 2, 3, 4, and 5. That right there, that's your range of feasibility, and this little chunky dunk right there. And I wrote this all out, and it's asking you what is the optimal blend. So I imagine they're going for cheapest. So again, here's the equation. I'm sorry, it's over the letters, but just bear with me. I just plug these into here because that's all you gotta do with linear programming. It's super easy. All you gotta do is plug these into here once you find the parameters. And this one is also really easy because it gives you just 3 things that you gotta do. And then it gives you, this one even gives you X and Y, which is just very, very nice. And yeah, all you gotta do is plug it in, and these are the answers: 1.2, 0.8, 0.6, 0.4, and 0.6 again. So this right here, fairly certain, would be the minimum, which again is your answer. So you gotta do. That's all you gotta do. It's all you have to do, man, to solve this. Is find whatever it's asking for and the parameters, and then you gotta graph it and plug it in. It's so simple. So thanks again for watching. I'm Stat Callahan from College Early High School of Wilmington. We're really cool, and that's about all I have to say about linear programming. Really cool concept. I enjoy it. I give it 3.5 all day every day. 3.5 all day every day. That's just what I'm all about. And so thanks for watching. Please watch other videos on my channel. They're pretty good. They're not that great, but they're pretty good. So drive safe, have a fun time.